In this tutorial, we are going to solve the problem number 6, and this is easy problem, algebraic problem, and we have to here simplify our complicated expression and transform it into simple algebraic expression. For this, let's denote this part of our problem as A and denote this part of our problem as B. First, we are going to calculate A, simplify A, and then we are going to simplify B and multiply A by B and find what is a simple expression which is equivalent to our complicated expression. First of all, using a result that assume we have a quadratic polynomial or polynomial of degree 2, say a x at squared plus bt plus c equals 0, it can be represented as a t minus t1 times t minus t2 equals 0, where numbers t1 and t2 are roots. t1 and t2 roots of this equation, and to find these roots we have several results. The most important result is the theorem of Bézout. It is result that follows from Bézout theorem that these two roots, t1 and t2, divides our free member C. So t1 and t2 divide C. And using this result, we can perform a representation. We can represent our first denominator as t plus 1, because number minus 1, if we insert in this equation, will give us 0. Then we divide this polynomial by t plus 1, and after division we will have t plus 2. That's why our polynomial in denominator, t squared plus 3t plus 2, can be represented as t plus 1 times t plus 2. Along the same way, this polynomial can be represented as t plus 1 times t plus 3. And this polynomial can be represented as t plus 2 times t plus 3. And using this, we can rewrite our A as A is equal to 1 divided by t plus 1 times t plus 2 plus 2t divided by t plus 1 times t plus 3 plus 1 divided by t plus 2 times t plus 3. t plus 2 times t plus 3 squared. And now, if we perform a summation of these three algebraic fractions inside brackets, we will have a total fraction, and denominator of this fraction will be a common multiple of these three denominators. This is t plus 1 times t plus 2 times t plus 3. In this case, the first numerator must be multiplied by t plus 3. This numerator must be multiplied by t plus 2. And this numerator must be multiplied by t plus 1. And rewriting it, we will have t plus 3 plus 2t times t plus 2 plus t plus 1 is equal to, denominator will be the same. We just rewrite it, combining like terms. So it will be 2t squared, 2t squared plus 6t plus 4. And if we take out number 2, we will have t squared plus 3t plus 4. And denominator is the same. This quadratic polynomial in numerator can be represented as multiplication of two brackets, t plus 1 times t plus 2. And let's rewrite the denominator. Denominator was t plus 1 times t plus 2 times t plus 3. Now we perform cancellation of this. We actually forgot to put here squared everywhere here. So we will have 4 divided by t plus 3 squared. This is our A. This is our A. Now let's calculate B. Let's first of all rewrite our B. B will be equal to t minus 3 squared plus 12t divided by 2. If we perform shortcut multiplication here using formula a minus b squared is equal to a squared minus 2ab plus b squared, we can rewrite it as t squared minus 6t plus 9 plus 12t divided by 2. It will give us t squared plus 6t plus 9 divided by 2. And now, using another formula, that a squared plus 2ab plus b squared is equal to a plus b squared, we can rewrite it as t plus 3 squared. This is a b. This is our b. And now we have to multiply a by b. So a times b will be 4 divided by t plus 3 squared times t plus 3 squared divided by 2. Here we have a cancellations, and this is 2 times 2, and answer will be 2. So 2 is the final answer for our problem, and this complicated algebraic expression is equal to 2. It was everything for this tutorial. Thank you very much.